So you all know vector is a quantity which has both magnitude and direction. So there are a few examples over here. So there are few examples over here for vectors which has both magnitude and direction. Say force, velocity, acceleration. All these things has the direction as well as the magnitude. The values also you have for that. What is a scalar? Scalar has only magnitude. There is no direction for scalars. Example, you can take the length. It doesn't have any direction. Volume, it has only magnitude, no direction is there for the volume. Only values will be there. Length is so much feet, so much height. Volume, so much. Some say volume is equal to say 264 centimeter cube, okay, or 1057 square feet is the volume of this. So some volume, some value parameter for volume, length, some numerical values will be given. Okay, there is no direction for that. Now how do you find the magnitude of the vector? Vector is represented as if you write P, then on top of that you will have an arrow mark. That is the notation for vector. So magnitude of vector is given by both the sides of that point. You have a modulus sign, modulus of PQ vector. Okay, so P is the starting point, Q is the ending point. Magnitude is given by modulus of PQ vector. So in this diagram, if you see, P is the starting point, Q is the end point. P is a point with x1, y1, Q is a point with x2, y2. How do you find the distance between these two vectors P and Q? It is given by root of x2 minus x1 whole square plus y2 minus y1 whole square. So that is the magnitude of 2 points. If you have just one point, say x1, y1 only you have, then how do you find root of x1 square plus y1 square? That's all. If you have 2 points, then subtraction is required. Remember that. Okay, it might be asked in multiple choice questions. So if one vector is given, say how vectors are represented. In x direction it is given as I cap, in y direction j cap, in z direction k cap, like this it is given. So if one vector means how it will be given, say 2i cap plus 3j cap plus 5k cap. Then if they ask you to find the magnitude of that vector, it is square root of 2 square plus 3 square plus 5 square. That answer is the magnitude of that particular vector. Only the constant terms, squares, you have to add and take the root and give the solution. Unit vector. So how do you find the unit vector? So unit vector, if the magnitude of the vector is 1, then we say it as an unit vector. So unit vector in the direction of the vector A is given by A cap. It is denoted by A cap. And the answer is vector A divided by magnitude of vector A. Just now I told you how to find the magnitude of a single vector. Okay, that is square root of the I component square, j component square, k component square. That will be unit vector. We will do it further. Okay. Now position vector. Position vector, it is defined as a vector that indicates either the position or location of any given point with respect to the reference point. Okay, so from a point, say for example from origin to one point, that will be the position vector from the origin to the point. So from origin to that point, say x, y, z, how do you denote it? As I told you, v is equal to xi cap plus yj cap plus zk cap. That way we are denoting the position vector from the origin. Now the position vector of a point P with respect to the fixed point O is the vector R vector, which is given as OP vector. That is what I told you. R vector is xi cap plus yj cap plus zk cap. That only they have given here. Okay, where I, j, k are the unit vectors. along the directions x-axis, y-axis, z-axis. Product of two vectors is given by, if there are two vectors, say a vector and b vector, okay, where a vector is say x1 I cap plus y1 j cap plus z1 k cap. B vector is x2 I cap plus y2 j cap plus z2 k cap. Then how to find the product of two vectors? You have to multiply a vector and b vector. That will be the multiplication of two vectors. And a vector cross b vector is the cross product of two vectors. Okay. So the cross product is different and the multiplication is like so it is different. The dot product is different and the cross product of two vectors is different. We will see with an example in the future case. So dot product of two vectors gives the different answer. Cross product of two vectors gives the different answer. Okay. And scalar product is different, vector product is different. Okay. Scalar product means only the scalar multiplication will be done in that product of vectors. Vector product means only the vectors will be multiplied and the result will be obtained. Scalar or dot product, as I have told you here, the dot product formula is given as, if you see here, if A is a vector, B is a vector, the dot product is given by magnitude of vector A into magnitude of vector B into cos theta. Okay, so you have to find the magnitude of A, magnitude of B vector and multiply it with cos theta so that you get the dot product of the vector. We also say it as a scalar product. Okay, scalar product of two vectors. Theta will be obtained from the angle between the vector A and the vector B. That will be theta. Okay. Now useful results, if you see here, you remember this. Always I cap into I cap, when you are multiplying I cap into I cap, you will get 1. J cap is 1. K cap is 1. But Ij is 0, Jk is 0, Ki is 0. Okay. So that is what it's mentioned here. I is like A vector into B vector into cos theta, right? Magnitude of A is 1, magnitude of B is 1, cos of the 0 vector is equal to 1, cos 0 is 1, right? So 1 into 1 into 1 is giving you 1. So you just remember in this way, you don't need to derive all this. You just remember that always I into I, J into J, K into K is 1. If you have different I, J, J, K, K, I, then it is going to be 0. Okay, that's all. Now here vector product I told, right? A cross B. So how do you find that A cross B? You have to take the determinant of IJK in the first row. Second row A1, A2, A3, that is the components of A vector. Third row B1, B2, B3, components of B vector. So this will give the cross product of vectors. That's the formula. You no need to compare it with magnitude of A, magnitude of B into sin theta income. No need that. Just remember A cross B is the determinant of IJK, A1, A2, A3, B1, B2, B3. That's it. Once you solve the determinant, you will get the cross product of two vectors. Again here, you remember that here it is different, quite different. I cap cross I cap is same as J cap cross J cap is equal to K cap cross K cap is equal to 0. Okay, but dot product is different, cross product is different. Remember, I cross I, J cross J, K cross K is 0. Okay, similarly I with J will give K, the other vector. J with K will give the other vector I. K with I will give the other vector J. Okay. And J with I if you have, it is minus K. If you have in cyclic order I, J, K, I cross J gives K, J cross K gives I, K cross I gives J. But if you have the other way, J cross I will give minus K, K cross J will give minus I cap, I cross K will give minus J cap. That's all. Okay, so here you have to just remember I dot I, j dot j, k dot k is 1. I cross I, j cross j, k cross k is 0. These two things you remember, nothing more. Vector point function. So it's a definition like if you have a point p of x comma y comma z and there is a vector r where xi cap plus yj cap plus zk cap is given. So this r vector is said to be a vector point function of t, where t is a single parameter, where x, y, z, I told you know x, y, z are functions of t, then we say it as a parametric equation. That is the way it is given here. P is a point x, y, z, r vector is a vector where x, y and z depends on t, then r vector is said to be a vector point function of t. Okay, that's it. Now derivative of a vector point function. So this is like differentiation of the vector r with respect to t. Okay, so it is simple, but here it is given in delta and all that. I'll explain it to you when we are doing the problems. So vector A, if you have a vector v, then how do you find the acceleration? So acceleration is given by dv vector with respect to time, rate of change of velocity with respect to rate of change of engineering fields. If you want to know the rate of change of velocity with respect to time, or if you want to find the acceleration of some moving particle, then you can use the differentiation and you can find the solution. So that is how this differentiation and vectors are used in physics and in all the other engineering fields. So if you are differentiating the vector v with respect to t, you will get the required solution. Now scalar point function. Scalar means if you have say some point x, y, z in space, the scalar is nothing but a function of x, y, z, that's all. Means if I say there is some point in space x, y, z, okay, scalar point function means the function of x, y, z. So I can take x plus y plus z. It is a scalar point function where the function is depending on x, y and z. Vector differential operator is a very important formula which you have to know. So here this del, this symbol del, it is called as del. Okay, it is read as del. So this formula is very important. Del is equal to I cap times dou by dou x plus j cap times dou by dou y plus k cap times dou by dou z. This is the very important formula which we will be using to solve the vector differential operator. Okay, some function will be given, so we will find I cap times dou f by dou x plus j cap times dou f by dou y plus k cap times dou f by dou z, which is equal to del f. Gradient of a scalar point function. So gradient, I told like if phi of x comma y comma z is a scalar function, instead of f I have phi here, that's all. How do you find the gradient? Gradient of phi is equal to this formula you have to use. I cap times dou phi by dou x plus j cap times dou phi by dou y plus k cap times dou phi by dou z. This formula we have to use and we have to find the gradient of the function phi. Properties of gradient, it's just same like gradient of two functions. Gradient of f plus g is grade f plus grade g. Gradient of fg is f into grad g plus g into grad f. Okay, if c is a constant, you can take outside the gradient. Gradient of f by g is not grad f by grad g, it is like a what is that, quotient rule of differentiation, like that. So g into grad f minus f into grad g by g square. Okay, this is what is the quotient rule, right? So it is similar to that. So normal vector is, if a function f is given, then normal vector is nothing but gradient of f is the normal vector. Friend, unit normal vector is del f divided by modulus of del f. Okay, del f divided by modulus of del f is the unit normal vector. Formula is important. Remember the formula. It might be asked in MCQs. Okay, or it might be asked in a problem also while solving the problem. Unit normal vector. Del f by modulus of del f is the formula. So del f means, I told you how to find the del f, vector point operator, vector differential operator, that is del f. We'll solve the problems. Okay, so this is all the theory about vectors. Now we will try solving the problems based on this.